In an exam, you will always get a periodic table, and especially in chemistry, you have either AQA, Edexcel or OCR. They will all have the similar type of periodic table they will supply. The first thing you will need to think about is this. On that periodic table, you need to mark in a step, and that step goes between boron and aluminium, and then it starts going down like this, a nice little step. And the importance of this step is that it separates the metals from the non-metals. And what you'll notice is that all of the non-metals are on the right hand side of the step, and all the metals are on the left hand side of the step. That's the first thing, and it's useful because if in an exam you're ever given formula of a compound and you can identify whether the elements are metals or non-metals, you'll be able to identify if you've got a combination of metals and non-metals in that formula, then you've got an ionic compound. Whereas if you've got just symbols which have got non-metals combined together, then you'll know that they have covalent bonds. So that's why that's important to establish where the metals and non-metals are in terms of their position in the periodic table and their symbols. The next piece of information, which is really important, is this number down here. We've got 1, 2, and you've got 3, 4, 5, 6, 7, and 0. Those numbers are very important because those numbers, I'm going to color code it here, those are the group numbers. And the group numbers are really important because they tell you the number of electrons, and I'll put number of electrons, and I'll put E minus as electrons in the outer shell. Okay, so that tells you the number of electrons. The group numbers tell you the number of electrons in the outer shell. So if we took, say, lithium, sodium, they're in group 1. So it's this vertical column, yeah, that group number refers to. All those elements in that group 1 have got 1 electron in the outer shell. So what they will tend to do, they will tend to lose that 1 electron to get a full outer shell. If you go down here, say boron, aluminium, they've got 3 electrons in the outer shell. Here you've got fluorine, chlorine, bromine, group 7. They've got 7 electrons in the outer shell. And that's what that group number tells us. And so you can find that from the periodic table. The next piece of information from the periodic table, which isn't really shown here, okay, but we can put in, are these horizontal rows. Now we've got hydrogen and helium here, and I'm going to put the number here a number 1. Because that is period 1, and this is the word now, we're using the word period. I'm going to put period up here. So here we go. I might bring it down a bit so we're on screen, I hope. There we go. Period. Okay, and that's the period number. And look, lithium, beryllium, boron, carbon, that's the horizontal row there. That's period 2. And then you've got period 3 for sodium, magnesium, and so on. Period 4 for potassium, calcium, scandium. I'll put them all in period 5, period 6, period 7. So those are the period numbers. Now, the period number tells us the total number of electron shells. That's why that's really important. The period number tells you the total number of electron shells. So if we looked at period 1, where you've got hydrogen and helium, they've only got 1 electron shell. And that's that very first electron shell, which can have 2 electrons in it. Whereas period 2, where you've got lithium, beryllium, boron, carbon, they've got a total number of 2 shells, 2 electron shells, where in the first electron shell, you have 2 electrons, in the second electron shell you can have 8. So there's 2 electron shells there. For sodium, magnesium, aluminium, silicon, and so on, 3 electron shells. So that period number, which is the horizontal row number, tells you the total number of electron shells. And then one last piece of information which I think you should all know, okay, and that piece of information is this. With every element, Okay, this is the fundamental bits. Say, I'm going to take, say, lithium. I'm going to bring it up here, lithium. And there you go, I'll put lithium up here, Li, and the two numbers which are associated, 7 and a 3. Now that 7 is known as the mass number. Okay, and that 3 is known as the atomic number. And so I would hope, just to recap with you all here very basically, that you would know that the atomic number tells you the number of protons, and the mass number tells you number of protons and neutrons. And so from this element here, we know that we've got 3 protons, so lithium will have 3 protons. It's going to have 4 neutrons. One other piece of information you need to know is that that 3 also refers to the number of electrons in a neutral atom. So it's also the number of electrons, but in a neutral atom. And in this case, we've got 3 protons, 4 neutrons, and we've got, therefore, that atomic number is 3. So we've also got 3 electrons. I hope you found this useful, how to extract information from a periodic table.